Hello everyone, this is SIG Scheduling meeting on May 28th. And we have two things on the agenda. Support for min domains no-taints policy. Derek, you want to start?
Yeah, folks can open the doc as they'd like. The problem I'm trying to solve is a simple one. When a zone is completely down in a cloud provider use case, topology spread constraints break and users cannot scale up. So users have to decide between having their TSC give them horizontal availability prior to the event or giving them ability to scale up during the event. And they cannot make a declarative statement in the Kubernetes scheduling language that says, I would like both of these things. I have proposed a solution for this here that does not require any like autoscaler or cloud provider specific information, given that like complete outages will cause the node to get tainted because kubelet stops heart beating. Um, I wanted to get your guys' opinion on it before I wrote a full cap, but that's the next, and I wanted to know if that's the next step, basically.
Yeah, I was looking into it, and my first this is the problem that comes back from time to time, and there are different flavors of it, but here I think we're trying to address the problem when the whole zone is or domain is not available, and we detect it only by the fact that all the nodes are tainted. Is that correct?
Yeah, which would happen if because kubelet would stop heart beating across the zone. For what it's
So
worth, I'm also coming at this from the perspective of EKS, where we've built a system where users can hit a button to taint every node in a AZ. So it's we already have the integration, and I'm hoping to work with that. But it works even if there isn't that integration, right? Like a normal cloud provider or a other cloud provider has that possibility as well.
so in other words, we are saying that this is one of the cases in which we don't have to honor this the min domains.
Yeah.
On the other hand, it's it's similar problem to the initial scheduling problem and the updates to the already scheduled pods. Because if we are discussing workload hour scheduling and, for instance, min count, then the min count is supposed to be honored at the initial scheduling, but what happens later should be considered a little bit differently. So I think in this case, when we consider that the pods were already scheduled and the number of domains drops for whatever reason, maybe we should not honor the min domains anymore because the pods were already scheduled, right? If the
It's
min
saying
domains
like,
were not met at the initial scheduling, we would not schedule anything. Since something was scheduled, that means that those min domains were initially met. So do we need anything more?
well, the you want so if the you want min domains to skew to still apply to min domains, or else you could get in a situation where like you have one pod in one zone and like a million in another because you're like, oh, I've satisfied my min domains count. And so you actually do need to say like your skew is trying to say I want to satisfy skew across this number of domains, right? But you need to have this like exception, which is like when there is like no availability in that topology domain, maybe we say we've satisfied it. And tainting
Okay,
can be that
because
signal.
because the domain actually still exists, right? But it's
Yes.
not use. Okay, okay, that's
Because right now
important distinction.
the scheduler doesn't know that the autoscaler can make new nodes in domains. And so we've built this kind of like min domain structure to tell the kube scheduler like, hey, actually you should mark these as unschedulable because then the autoscaler will take over, right? And right now that's the only way that the kube scheduler has to say I'd like this in a zone that doesn't exist yet. But uh, you want that to turn around when the autoscaler can't provision capacity. And so there was another proposal I think that Justina from GKE was pushing that was about like autoscaler specific signals. I think that's been subsumed into the scheduler driven autoscaler conversation. Like I think that's where we'll build that. But this use case, the use case I'm arguing for is actually for a static cluster, which is in a static cluster, if you can't schedule into the minimum into all like if you can't skew across all three domains because it's so domain is entirely tainted, but you have room in other ones, maybe you still want to schedule anyways. And it doesn't break auto scaling um, if that makes sense.
Yeah. Well, briefly thinking about this, it makes sense. Uh, Anyone has a different opinion about that? I'm not sure how it interacts with auto scaling, but I think once we have a like there okay. So I haven't reviewed the former proposals, but as you are saying, those are more focused on the dynamic, obviously, clusters, and your proposal works also for static clusters. So if auto scaling guys does not have any concerns with that,
I did bring it to SIG auto scaling first, and they said that they're generally okay with it, but they wanted to as input. I'm from SIG auto scaling. I'm one of the Carpenter maintainers, so I'm confident it works for auto scaling, but I can get better signal if you want more definitive buy-in from like some of the CAS folks. Is the next step to write a KEP and then get people to argue in the PR comments?
yeah. So right. So one thing is obviously our which is always a concern, the reviewing capacity, but that's something like quite orthogonal. I think the change itself shouldn't be that big. Mm. So I think we could proceed with a cap. Wojtek, do you have any opinion?
No, I think that sounds fine, but I didn't have enough time to think about it. But like, I don't have any concerns, at least from the top of my
Yeah.
head.
So the way I understand this is, we are in fact trying to define a case when we can really consider that that something was scheduled, but the one of the domains is simply not available, and the question is how we define those constraints. And we can also think like about the performance impact, but currently we will see during the cap review, but currently I don't see any signals that it may degrade the performance significantly. So at the
Yeah, I can do
first
some
glance,
heat maps and stuff and like some performance testing as well when it comes to during I can like prototype it during the CAP process as well to make sure that folks are okay with the performance.
Yeah, that would be super helpful, definitely.
Yeah. We see the same problem in Carpenter where people are like, I want to make this change to Carpenter scheduler. And we're like, you might break everything, please, please. So
yeah, we definitely can think about like using workload hour scheduling to achieve a similar like goal for topology spread, but I think it's too far on the horizon until we get there, and we could probably do some smarter things because we would have more data. But yeah, that's.
I actually think that like workload aware scheduling kind of, but mostly with the scheduler driven autoscaling that we're talking about, where like the scheduler knows things about autoscaling, I think is the right behavior for this, because the autoscaler will be able to say like, yes, I can make capacity here, and no, I can't make capacity there. It'll like have a way to give a dynamic signal into the scheduler saying where new nodes can be made, and the scheduler can use that information intelligently to like fall back to like not other domains and like violate skew maybe. Like we might actually want to re-architecture or like completely rewrite topology spread constraints once we have that information, because the semantic becomes different. You no longer have to design around like not knowing where new nodes can come up. Now you do know, and you get to design a functionality that actually implicitly understands the auto scaling. But I'm not waiting for that. We'll do that next year type of a thing.
Okay. Sounds good. Thanks. So the next item is from Praveen.
Hey, yeah, thanks, Dominic. Can I get permission to share my screen?
Okay, you can try now.
Okay. So, yeah, I wanted to give a quick update on the DRA for node allocatable resources kept that we've been working on. This went alpha in 136, and the plan is to do another alpha for 137. Uh, for alpha 2, for alpha 1, just to give like a quick overview, like most of the changes, or in fact all of the changes, were on the scheduler side to handle the accounting part correctly. So scheduler, today we introduced a API on the resource slice, where we say like a device maps to native resource, and currently in the dynamic resources plugin, we basically do the overall node resource fit check, where we consider like standard request from pod spec and DRA requests from the claim, and see if the node has enough resources or not. For alpha 2, I think like the primary goal is to bring in or consider DRA for the C group enforcement part on the kubelet side. So kubelet will take a look at like pod spec, pod level resources, and along with that it will consider DRA to set the like request and limit on the pod side. And along with that, like there are some changes on the API that we are proposing. So basically like earlier in the in alpha 1, like the resource slice API had a mapping where we could say like if a capacity, like a capacity in the resource slice, if it maps to node allocatable capacity, uh, we have a key which maps to consumable capacity, or we have a multiplier which says like this device accounts to this many CPU or this much memory. With alpha 2, we want to go a step further and say that like in the resource slice we have two types of mapping. One is the direct mapping and one is the overhead mapping. Direct mapping is mostly for like DRA drivers itself, like CPU or memory DRA driver, which also, which directly allocate the capacity. Overhead mapping is for use cases where like an accelerator would want additional CPU or memory. So I think it may be a little better with the examples. Let me. So yeah, this is what I was referring to. Basically it's like within the resource slice, this is a resource slice for CPU DRA driver. We have node allocatable resource mappings, where we say direct mapping, this maps to this key in the consumable capacity part, and there is an additional multiplier if we want to translate it to like what is represented in the node info. And the other case is for accelerator type devices, where we say like this accelerator comes with an overhead of some additional like memory, for example, where we say like every time you have a resource claim with this accelerator, you add this amount of memory, and this comes with two configurations, like one is per pod reference and one is per container reference, which basically means that like if we have a accelerator, if it is referenced in two containers within the same pod, for every container account 500 MB of memory. And per pod reference means that if a claim is referenced within the pod, for every pod that is referenced account for this much amount of memory. So basically on the scheduler side, like I think the changes will continue to be in the dynamic resources plugin, where currently we only have this direct mapping and we compute the total consumed amount of CPU or memory. But here, like with this new addition, it'll look at like number of containers which are referencing the claim, and based on these configurations it'll compute the total memory and account for it from node info. So I think that's the main change on the scheduler side. How we enforce it on the kubelet, I think we already like in alpha 1 we proposed some changes in pod status, where we say like I mean all the allocations that is done by the scheduler is recorded in the pod status in the form of node allocatable resource claim status, and kubelet will use this to set the C group boundaries on the node level. So I think that is like a very high level overview. So I have a kept that is already up, and there is some ongoing discussions on that, but mostly wanted to get some feedback on the scheduler side if there are like any major concerns around this.
Okay, so we have a change in a kubelet based on the status that we already provide, right? So
yes. So kubelet will look at this and set the C group values.
Okay, so the change is mainly in the API to...
Yes.
So far we had this direct
Yeah, I
option,
think
and now we have overhead.
so right now we did not call out specifically whether it's direct or overhead. All we had was like how a claims capacity maps to node allocatable capacity, and it was always like direct. Now like we want to call out the use cases and make it more distinct and say that like if you have a DRA driver which is allocating CPU or doing some C group changes for CPU or memory, it is direct. If you have a DRA driver which only cares about like getting some additional capacity without actually modifying anything on the like at the node level, we have this overhead. And an additional constraint is that like for a given resource slice or a given device in the resource slice, you can either have direct mapping or overhead mapping. So there is no use case as such to say that like we'll need both of these specified. So yeah, I think this would make the use cases more distinct mainly. And the accounting side on the scheduler will look at both of these to compute the total footprint, update the pod status, account for like the capacity on node info, and kubelet will use the status to update the C groups.
Okay, so shall we like prevent using both at the same time, or we simply don't have CA use case?
Yeah, I think currently what I've called out in the cap is like we maybe it's not update, but we can make some validation checks to see if both direct and overhead are specified and prevent like both of them at the same time.
Yeah. So well, the change is not significant. It's mainly usability for
Yes.
the use cases that you see, and I guess
Yeah.
the use cases are listed, so probably
Yeah.
we will see the cap.
Yeah. I think this time, I think the significant changes will be on the kubelet side for considering like standard spec pod level resources and now DRA to set everything correctly and all the eviction and all of those things. So I've listed those as well in the cap, but on the scheduler side, I think you're right. Like we'll have to see more fields to account, but the way we account and how we push it to kubelet, the mechanism like still remains the same. I think one thing to call out is like last time there was a lot of discussion on whether we want to like consume from claim and things like that, where we wanted to say like this is the standard request, but instead of node info we want to we want this to be consumed from a claim instead. I think we have separated or made that out of scope for this cap. There is another like issue that is open to look at this at a more broad level, where we can like explore having a reservation that can be consumed from different workloads and things like that. But yeah, like that is not planned for 137, and I'm planning to take a look at it like after the 137 cycle. So that is kind of out of scope for this skip.
Okay, can you remind me what is blocking the beta promotion of this?
One, the API change. So that, and also we want to do another alpha. I mean, with alpha 1 we don't have anything on the kubelet which enforces at the C group level. So that and API change, I think we would need another alpha to make these changes.
Okay, are there like other blockers that we have identified that something needs to be addressed before beta?
I don't know if it's a blocker, but a couple of things that I have called out is like one is the quota. That part still needs some discussion because the current quota for CPU and memory, we only have like it only considers the standard request and limit. So with DRA, like we need to see how that can be considered. So that I've called out in as a future enhancement, and we need to do like I mean, we need to look at it more closely, I think. uh, I've called out scoring as well. Currently node resources fit plugin, like we only look at the pod spec, and uh, I haven't still looked more deeply into if we need to consider DRA as well, and how we account for it during scoring. So these are the two open things, but I don't know if there are like beta blockers yet or not.
Okay, so yeah, scoring was one. I think one of them. What about preemption? But is there any like impact on that?
I think like this would be a part of like there is work going on preemption for DRA, right? I think Morton is looking into that if I'm not wrong, but
Yeah.
I yeah, I haven't looked into if there needs to be any change on handling the preemption.
Okay, because in the pod status we have the final resources that are computed by a pod, right?
Uh-huh.
So during the preemption, are we considering the resources that we wrote down into status or resources that we have in a pod spec? I don't remember.
Yeah, I think this is a good point. I can look at it more closely. So on the kubelet side, along with C group enforcement, another thing that we would be adding is like there is a pod status resources, which actually looks at the C group values and publishes and puts it in the status. So even that would now include whatever like C group changes are made through DRA. So I don't know if that automatically takes care of the preemption thing, but I can definitely like take another look and see if there needs to be any changes there. So on the kubelet side, to summarize, like one is the C group enforcement part that considers DRA, and two is the reporting part where we read the C groups and put it in pod status. That would also consider DRA. So and in both the places, like I think I think preemption part I'll need to look at it like more closely. So quota, preemption, and scoring are the three open questions.
Okay, since we are not going to beta, we don't have to
Okay.
solve probably those now, but yeah.
Yeah, that's everything I had. So mostly looking for like feedback on the cap. So Dominic, should I assign you as a reviewer, since last time I think you and Mache both looked at it, but this time I don't know like who's the right.
Yeah, I think you can start from me. If
Okay.
something changes, then we will look.
Okay, sounds good. Thanks.
Okay, so is there anything else, any other topic we want to discuss? If not, then I think we can finish earlier. So thank you, everyone.
Thank you.
And have a good day. Bye.